I'm Jeremy Ashkenas. I work for documentcloud.org, which does primary source documents for journalists. It's a nonprofit run by the Knight Foundation. I also work for interactive news at the New York Times. And one of the nice things about Document Cloud is that because it's a Knight News Challenge project, everything that you do is supposed to be open source. So we've been lucky to be able to open source things like _JS, Backbone.js, Jamit, and all that kind of fun stuff over the course of the past 2 years. And so Coffeescript isn't a Document Cloud project. It's a fun side project that comes from writing a lot of JavaScript all the time, day in, day out, mostly on the client side, a little bit on the server side, and doing sort of rich web applications where you have a lot of state and a lot of interaction happening in the browser that's not necessarily going on in terms of Ruby. So this is the only time I'm going to ask you to do it, but how many folks in the room have gotten a chance to play with Coffeescript before? Wow, that's crazy. All right. So Coffeescript's a little language that compiles into JavaScript. It's been around for about a year and a half now. And this is especially fun because the initial version was presented at an NYCJS, I think in January of 2011, and, or sorry, 2010. And the original version of the language was a good bit different than it is now. You'd probably recognize it, but it wasn't really the same. There wasn't significant white space. You'd use periods to end a block, kind of like Potion does, which is Y's little language. You used colons for assignment interchangeably inside of object literals and also for variables, which was something that we took out to make it easier to avoid using curlies later on. And functions were always hash rockets. And the original version of the compiler was also written in Ruby. So it started out as a Ruby project that generated JavaScript and then eventually became self-hosting. And one thing I should mention is that this is probably going to be more fun if you don't save your questions for the end, if you think you have something to add to the conversation. So feel free to raise your hand or shout it out, and we can get into it. Because a lot of this stuff is stuff that is good to debate, and lots of different languages take different stances on it. So the original version of the compiler was written in Ruby. It used a handwritten Ruby lexer, which was basically just doing regex scans on the beginning of the input string and pulling out what the next token was, and a rack parser. And if you ever played around with rack, I'm not sure if it was in the standard library or just a really, really old gem back from the days of RAA. But it's a nice sort of Yak or Bison style parser generator where you can specify what your rules are for building up your parse tree, and it recognizes sequences of tokens and builds them up in Ruby. But fortunately, things started working out pretty well sometime between 0.1 and 0.5, and the language started being able to cover a large enough area of JavaScript that you could write just about any program you'd write in JavaScript in Coffeescript. So for 0.5, an effort was made to get the compiler to be self-hosting, and what that means is I did a sort of a straight port of the Ruby compiler into Coffeescript, committed in the same repo alongside, just translating across what the equivalent idioms were. And so I was using the Ruby compiler, which was in the repo, to generate the JavaScript version from the Coffeescript source code. And for a long time, of course, it wasn't really working. It could only do toy programs. It couldn't really cover all of the syntax. But then you have a moment where it becomes complete. And so the Ruby compiler reads the Coffeescript, spits out the JavaScript version. You run that JavaScript version on the Coffeescript version, and it spits out another copy. And then you do that one more time, and then you're sure that it's self-hosting and it's working. And then the next step, of course, is to throw away the bootstrap. So you're kind of in the danger zone past that, but it's a lot more fun because once you're self-hosted, right, the first thing you do when you make a change to the language is you rebuild the compiler. And if you break your compiler, you no longer have a working implementation to do anything with anymore. So you've got to basically, the general pattern is if you want to make a change, you do it, and then you recompile the compiler twice, and then you run the test suite, just to make sure that in the context of changing it, you haven't changed the way that the compiler is working. So there's a lot of git checkout lib involved in resetting it again and trying to make a good change. So all this stuff has gotten a surprising amount of attention and noise recently because JavaScript is kind of exciting right now, right? We're finally having a true renaissance in JavaScript after many years sort of in the wasteland of the DHTML days, right? So we have actual browser competition again. We have HTML5 APIs where most of HTML5 is just, code for taking JavaScript seriously and actually exposing APIs to do, important, realistic things on the client side. But the JavaScript renaissance also requires your participation. Because just like we need people like Charlie Nutter and Evan Phoenix building JRubies and Rubyist, the JavaScript community needs folks experimenting with languages beyond just what Mozilla and Google and Microsoft and Apple want to do, and work with languages and libraries that push JavaScript in new directions. And this isn't just something that I'm saying, this is something that the TC39 committee also says, who are responsible for standardizing the next version of the language. Because as a committee they have to do a consensus process, they have to answer to everyone, you have to pay money to be in TC39 as a corporation, and it's hard to do that kind of a consensus process, and they'd much rather be able to standardize de facto standards, things like jQuery and other popular JS libraries and patterns that arise in the wild that are used by lots of folks, and have that sort of a market of experimental ideas that we can play around with before we decide what's going to get codified and then baked into browsers and will never change again. Right? That's the one constant in JavaScript is that if you ship something, it stays there forever. So I'm going to talk about this briefly from the perspective of a little language that tries to play around with what's possible in terms of JavaScript. This isn't a corporate project. It's more of a thought experiment of asking all of the what-if questions that you come up with when you're working on a JavaScript application. So, what if you didn't have to worry about semicolons or trailing commas breaking in IE after you've tested in every other browser, right? What if you didn't have to wrangle the prototype chain every time you wanted to, inherit something? What would be the minimalist syntax for defining a function without having to type out, all whatever it is, 10 or so, 12 characters you need to do the smallest function in JS? What if you were working with a language where the value of this didn't change out from underneath your feet if you assigned a function to a variable? So the sort of general philosophy and slogan of Coffeescript is that it's just JavaScript. And I don't mean this syntactically, of course, because it looks very different. But semantically, JavaScript already has a really gorgeous sort of object model and flexible programming paradigm where you have prototypes and objects that can be composed just as easily in sort of a classy way as they can as sort of a grab bag of properties, object literal style. And you have this kind of a holy trinity of this highly dynamic structure where you have these objects that are very flexible. You have prototypes that you can kind of build your own object-oriented programming in a style that you prefer. And you also have first-class functions with closure scope as sort of the icing on the cake that gives you the flexibility to do a lot of this stuff that's more difficult in languages where the functions are more tightly defined as to where you can put them. And I think that Ruby is a case where this is true to a certain extent, right? Where you have to worry about, in Ruby, you have to worry about the difference between a method, an unbound method, a block, a proc, a lambda, and converting between them and the differences in semantics that happen. They're not entirely interchangeable, and you can use them a lot in the same circumstances, but you have to be sort of careful about that. And both that and the object model are much more straightforward in JS, right? There's only one kind of a function. It only behaves in a certain way. And there's no distinction between objects and classes, right? Any object can be a class if you use it as one or not. So we want to sort of embrace the limitations with Coffeescript of compiling into JavaScript. We're not going to run an interpreter, right? Because theoretically, you can do anything in JavaScript that's computable. Maybe some of you have seen that Unix PEP emulator that someone wrote up recently. That's a pretty amazing piece of work. But we don't want to have any interpreter, any VM, no intercepting calls to the greatest extent possible. So we don't want to have to add special functions to the global object that we're going to rely on, ideally. That's sort of the golden rule. We fudge that a little bit just for the cases where we'd be compiling very verbose code that can be made a lot cleaner in your generated JavaScript if it can be extracted into a small helper, but we try to avoid that as much as possible. So this is different than other sort of compile-to-JS languages like move, which makes it safe to extend all of the main core objects with helpful methods by changing sort of the iteration protocol and being extra careful about it, or Objective-J, where for every method call that you do against an object, it goes through an Objective-J message send functions that you can get things like method missing. But the price you pay for getting method missing is you have to always pass it through a helper function. So it's because the semantics of JavaScript are so flexible and permissive that you can sort of stretch and play with the language as you see fit, and that makes it an attractive compilation target for language experiments. But you don't actually have to compile into JS in order to compile into JS in a manner of speaking. So here's a fun example of Tobias Schneider's def.js, which uses some crazy value of tricks to get you sort of a Ruby-ish class inheritance syntax right there, which is a fun one. And here, this is actually also valid JavaScript. There's no pre-processing involved. This is Jed Schmidt's fab. But here we're talking about actually compiling into JS. So when you think about that, maybe you think of, and let's see how we're going to do this. I think I'll just flip back with mirroring. So you might think of things like this, right, as your output JavaScript. This is Python, CPython, compiled into JavaScript via mscript, and it works. But let's not go there. So instead of taking a non-JS language and doing something really fancy, let's take a non-JS language and compile it into plain old boring JavaScript. So here's some code that the Coffeescript compiler produced. And it's not super crazy, I hope. At least I hope you don't think that's super crazy. In a perfect world, if we're doing our job right, it would compile into the JavaScript you would have written in the first place. And one attitude that's common is that code like this isn't that hard to write, and there's not much value added in not writing it this way in the first place. You have your text editor tricked out with key shortcuts for filling out prototypes and putting in all of the braces and everything you need, checking your trailing commas and all that kind of stuff. But at the same time, people shouldn't be the compilers, right? We have machines to do that for us. So Coffeescript language features are usually created by taking design patterns in JavaScript that you write all the time and coming up with kind of an idiom for them. So what kind of language features am I talking about here? Things like significant white space, where instead of having to delimit your blocks with curly braces, you're indenting them anyway, so we might as well use that as the delimiter. And I know that this is sort of a funny holy war with Python and Ruby, giving each other shit for significant white space or lack thereof. But Ruby is also a highly significant white-spaced language. It's just not indentation sensitive, right? If you try to say def A1 end without putting new lines there, it's going to fail, and you have to either put new lines or semicolons. So it's just really end is the only difference in Ruby that you have that's not significant white space there. So that's one of them. Everything is an expression is, I think, a great quality that Ruby has taught us is very valuable. That would be nice to have in JavaScript. And we're sort of close to being there in JavaScript. There are expression forms of almost everything, right? If you have an if-else and you need it to be an expression, you can write it as a ternary, which is an expression. And you have, because functions are closures and can be substituted in many cases, if you need to turn something that would otherwise be a big, long statement where you're assigning values inside of it, you can often wrap it up as a function, call that, get the value, and sort of turn it into expression in that way. But CoffeeScript really tries to make everything an expression. So ifs, try catches, switch statements, all these kinds of things. Variable assignment. If you use var in JavaScript, that can't be an expression. I can't say x equals var a equals b, because that's a statement. But in CoffeeScript, you can do that. In fact, all of those things are converted to expressions for you. Bound functions, so that this doesn't swap out underneath your feet. Class sugar for prototypes, so instead of having to manually build up the prototype yourself, you get classes for that. Loops become comprehensions. Destructuring assignments, an idea that is in the next version of, classes are as well, but destructuring assignment is something that's in the next version of JavaScript that they're working on, where you can, because JSON gives you a great structure for defining structured data. It'd be nice if you could sort of pattern match against that and pull out the values that you're looking for without having to manually traverse the JSON with loops to get at it. An existential operator, because we know from Ruby that it's nice when 0 and empty arrays and empty strings and stuff like that aren't falsy. It's nice because 0 is a perfectly valid value for a number to be, right? When that's truthy, the existential operator helps you ask that question. Does the value exist or does it not exist? Splats, like we have in Ruby, default parameters, here docs and here regexes. Here regexes are kind of fun, where you can document a regex, kind of like you could break out a string into a here doc over multiple lines, or say you're doing a fancy SQL statement, you break it out into a here doc, break out your regular expression into multiple lines and comment it as you're in the middle of it. And then automatic lexical scoping, so there's no var involved and no accidental global variable creation. So let's dive into some of this fun stuff. And I'm going to mirror it again. And I hope you all like live code, because that's what we're going to do. So, getting started with the basics. Right? We have can everyone see that? Is that too small? Or is that all right? Bigger? There we go. All right, so square is a function that takes a number x and returns x times x. So if we were going to try to bring this down to sort of the most minimal syntax we could find, what would we do? First, we could take off the semicolons, right? Because who needs semicolons in this day and age? Second, if we're going to do implicit white space, significant white space, I'm sorry, we can take off the curlies, and we can use the indentation to delimit this. We don't need a var, right, because we're going to have the variable declared for us. We don't need to return, right, because returns can be inferred. The last value of any sequence of statements is the return value unless you explicitly return. So we can remove the return. And then finally, that long function word, instead of using the word function, sort of the Coffeescript thing to do is to say a function is input goes to output, right? You take in your input, you return your output. So literally, arguments going in point to the arguments going out. So now we have our Coffeescript function. Square is a function that takes x and returns x times x. And if we compile this, we get back pretty much what we had to start with, right? So there's the JavaScript coming back out. And if you're curious about that, there's a TextMate bundle that hooks into the command line compiler where you can evaluate and compile Coffeescript. And that's just what I'm using for this. So that's a function. But there's lots of stuff that's great about JavaScript already that we don't need to change, really. So arrays and object literals, the kind of stuff that makes up JSON, is already a fantastic format. So that doesn't change much at all. We have arrays, and if we run, let's do it this way. If we run that, we'll get back Mo is the stooge at 0. And one difference here is that Coffeescript object literals are they can be written like YAML if you use significant white space to delimit your object, and you can leave off the trailing commas at the end of the lines. You can use the new line to say this is a new entry in my object, and you can leave off the curlies because the key colon value defines, kind of like in a hash in Ruby, you don't need to put the curlies if you're passing it to a method. So when we compile this, we get back the JavaScript object we expect, and we can see that elements.silicon is indeed 14 here. And this is optional, right? You don't have to write it like this. If you're more comfortable writing it explicitly with commas after it, even with a trailing comma on the end, that would be a problem. But let's see what that compiles into. It's going to fix it for you. So you just don't need to worry about them. All right. White space, probably pretty self-explanatory, but if today is Saturday, then GORUCO. And indeed, today is Saturday. Comprehensions. So one of the things that we learn from Ruby is that you don't really need explicit loops in most cases when you're dealing with data. Often when you're looping over something that you want to talk about, and you just want every key, you want every value in the array, or you want every key and value in the hash, or you want every value and index in the list. And the really, really fancy loops you can often do with a while if you really need to have that sort of jump the index around power. But writing out for loops by hand in JavaScript is something we want to avoid. And a lot of people do avoid this, unfortunately, by using each functions, jQueries each, or underscores each, or prototypes each, or ECMAScript 5s for each. But unfortunately, all of those, including the native one, is a good bit slower than writing it out by hand, so you can't really trust them for your innermost loops where it matters. But we can help fix that. So if we're going to log each, so here we have a list of letters, A, B, and C, and if we're going to log each letter in that list, we get back, oops, I compiled it, but let's run it. We get back out ABC, and if you compile it, you'll see that we're writing out the standard JavaScript for loop. So you get the full speed of the underlying JavaScript without having to write out the indexes by hand. And you can also do this to enumerate over objects. So because this is actually a Node.js interpreter, process is one of the global objects that has a whole bunch of keys. So if we look for every key in process, we're going to see all these sort of global properties that you have up at the top. These might look familiar, things like next tick and event emitter. But sometimes you don't have an array or an object to iterate over. Sometimes you just actually do have arbitrary endpoints. So that's fine. You can do that too with a range, right? So now we're going to log I from 0 up to 10 inclusive. And this is the same syntax as Ruby, right? That will be an exclusive iteration from 0 through 9. And we can do it by 2. So I for I in 0 to 10 by 2. And we can only filter certain clauses. So if we want all the even numbers, right? Let's say when I mod 2 is 0. And now we have just the even numbers. And what does this compile into? It compiles into the loop you'd expect, right? I from 0 to 10, I++ with the filter on it. And let's see, comprehensions. So the next thing let's do is let's turn this, so this has been a loop, right? We've been looping over and we've been doing something for every I. But let's turn it into a comprehension. Let's use the syntax as a value. So if we wrap this in parentheses, now we have something different, right? Now we have console.log I for I in 0 through 10. So that, oops, sorry, I ran the whole thing. That is going to be the array of I from 0 through 10. And so you can use this for objects, you can use this for arrays to get back out your computed value. So that's kind of using the everything is an expression idea, right? If what's the value of a loop, right? The value of a loop is its computation over everything that it does. Yeah. Got a question? That was just a hand raise. All right. So I'm sorry. This is the exact same example, right? The difference between, if we're going to inspect the difference between I for I in 1, 2, 3, and it as a comprehension is right there. And these both work prefix and postfix, right? So we can say for I in 1, 2, 3 indented block, do your computations in here. And this is going to give you back the same thing. And you can even use it for crazy things. You can use it for if-elses. You know what? Let's do that actually real quick. Let's say console.log if false 100 else 200, and when we run this, we will get back a parse error. All right, we have to save this. Nope, never mind. Take that one back. X equals if false 100 else 200, console.log x. It's the danger of the live demo, of course, is that you're going to get yourself into trouble. And you can even use it for crazy things like a try-catch, right? You ever wanted to pass a try-catch directly into a function or return it or assign it to a value? Why not, right? Let's console.log try missing object, catch error, and then wrap it in the string. And here we also have a string interpolation right there. And the error is. So we run that, and the error is reference error. Missing is not defined, because of course missing indeed is not defined. All right, so splats, shrink this one down so we can see it. In JavaScript, you have the arguments object, right? But the arguments object isn't the most friendly API to work with because it's not really an array, but you wish it were. So often you want to turn it into arrays so you can shift and do everything you need. So Coffeescript gives you a splat, which is the trailing ellipsis off the end of the variable name that collects the rest of the arguments to a function into a real array. And you can also use it when calling a function to expand an array of arguments into positional parameters. So kind of the same as splats work in Ruby. And you can actually also use it in destructuring assignment, which we'll see later, which is also fun. So when we run all of this, right, here we have a best actor function that takes the first argument as the winner and then the rest of the arguments as the others. And it says who the Oscar goes to, and it says how many runners-up you have. And when we run it with 4 actors, the Oscar goes to Jip O'Nolan with 3 runners-up. All right, the existential operator. So this is kind of a fun one. As I mentioned before, there's a lot of falsy values in JS. You have 0, you have empty strings as falsy when you don't really want them to be in a lot of cases. There's a lot of fun bugs that happen when you're expecting a number, all of a sudden you get 0, and then the else happens in your if, and you have to be very careful about that. So the existential operator says, is the value null or undefined? And if it's null or undefined, then it's false, right? And if it's anything except for null or undefined, then it's truthy. But you can use it to ask that question. You can also use it to soak up everything in the chained access that follows it, right? So here we're going to say, here we have an object assigned to the variable Sue with a name property that goes to Sue Jones and 27 years old. And if we log Sue.name.length, we're going to get 9 is the number of letters in Sue space Jones. But now let's try something else, right? So let's try this. I'm going to comment this guy out. Oops. I'm going to comment this guy out. And we'll do a non-existent property on Sue. So here, what didn't happen, right? This is what didn't happen. If we just try to do a dotted accessor and look it up, you get a type error because you've indexed into your JSON object into a property that doesn't exist. But you can use the existential accessor to soak that up and basically say everything after that point that you checked at is undefined, so you get back undefined. And you can do that sort of same thing for functions. So in this case, there is no reverse method on a string in JavaScript. So it's going to soak it up, and you're not going to get the error when you try to call it. You know, it's saying if it exists, call it. If it exists, access it. Otherwise, we don't have to try, which is more useful for side effects than it is for values, but it's handy for side effects. So this is one that I think we can talk about more at length if anyone wants to debate it. But Coffeescript adds a class. It didn't for a long time, but then we finally bit the bullet and did it because there's a lot of fun things you can do with this. Class literals, which desugar into hopefully the same prototypes you would have written, right? So you're building a constructor function. You're attaching methods to the prototype property, and then you can work with your new queue in this case, new fair queue, new safe queue, taken from the first talk today. We were talking about different strategies for getting queues done. And like Ruby, the body of the class here is executable. So you can say if debug, define this method. Otherwise, don't define this method. You can also make use of static methods inherited from the parent class, right? So if I have class book inherits from active record base, but in JavaScript, I can say has many, and I have access to that function, which can then manipulate the prototype and set up those sort of listeners and properties correctly. But let's do the basic example. So here we've got let's start with a queue, right? We've got a class queue. It's got a run function defined that logs distribute work. And so if we say new queue.run down here at the bottom, we have distribute work. Our fair queue function demonstrates extending a existing class. And you might ask, why are you using the extends keyword here? And why are you using the class keyword here? Part of the reason is because JavaScript has reserved those words because of keywords that Java had back in the day. So that means that using this doesn't conflict with existing JavaScript programs, because no programs can use extends or class as variables. So we can make use of them and not have to deal with that little entanglement. So we can extend queue here, and we can override the run function. And so when we run our fair queue, it's going to distribute work fairly. And we can override with the safe queue, we can extend fair queue, we can override the run function, we can log something, and then we can call super. And this is really where you get the advantage in dealing with classes, but except for verbosity of typing, where you get the advantage in dealing with classes instead of raw prototypes, because we can know at compile time what super is talking about, right? We can say, oh, you've made a call to super. You're inside the run function, and your parent is the fair queue. That means you want to call fair queue's implementation of run. Whereas usually in JavaScript, you have to say fair queue.prototype.run.call this, .apply this, arguments if you want to call super. Yeah?
Can you compile that to JS so we can see the
I can. Yeah. Let's do this one. So there's one extra step of indirection here, right? So you have your function queue, and then you're just attaching a method to its prototype. The one level of indirection there is that you have that extra function wrapper around it, and that's because of an IE bug. So if you used a named function in IE and you have a variable with the same name, IE gets confused and it clobbers the variable in a bad way. So that's just a safety thing to keep that from happening. And the reason why I want to use a named function there and not just a variable is because then you get the nicest names in your stack traces, right? You're going to have the name of the method in your stack trace. You're also going to have the name of the constructor function in your stack trace. Yeah.
Quick question. It looks like, do you support any private variables into Coffeescript and then translate it into JavaScript?
No, because we don't do private variables because, I'm sorry, repeating the question, yes. The question was, do we support private variables in Coffeescript? And the answer is no, because JavaScript doesn't have private variables yet. They're working on it, I think, for better or for worse, in the version of classes that's going to go into ES Harmony. And you can mimic it in JavaScript by not using prototypes and by basically using an object factory to create yourself a new object out of a closure with private variables that are only accessible because they're local to the closure. And the reason why you don't want to do that for high-performance JavaScript is because that means that you've remanufactured your entire object, including all of its functions, for every. So this is one of the common patterns as an alternative to using prototypes, is to say, oh, I'll just write a function that returns an object literal with all of my functions defined on it. And then every time I call that function, I'm going to get a new copy of the object. And that works great, except that you're also redefining all of your functions every time. So that means if you have 10,000 points, you're going to have 10,000 copies of all of the functions on points. And because they're closures and they reference variables in their scope, that eats up memory like crazy. So it works fine if you don't have too many objects. But if you have, these are objects, right? These are sort of the base level of your system. And you want to try to not have duplicate copies of everything. All right. Anything else on this one? Good to go. Yeah, let's do the whole thing. So that's going to include the helper for extends. So we don't have line breaks here. Let's zoom this out a little bit. We get a reference up at the top to has own property, and then we have our, this is one of the helper functions I was talking about. One of the few, I think we have maybe 3 that could be end up in your code. And we could write all of this in every case, repeat those 6 lines or so in every case for each of the functions. But instead, it's up at the top. And so all of your functions down here, all of your classes down here are going to be doing it like this, right? We have our fair queue, and we have our named function for fair queue. And you can see how by default the constructor, because if you're inheriting from another constructor function, you want to preserve the behavior of the parent unless you override it. So because we're not overriding it, it's gonna basically call super inside of the constructor function. And it's using the extends helper to do the inheritance. And then from that point on, it's all just adding methods to the prototype like you'd expect. And this is the kind of stuff you don't want to have to write by hand. And in terms of how the extends function actually works, most of it is straightforward. In JavaScript, you have to make a fake constructor because you can't inherit from a constructor function. You can only inherit from an instance of that constructor function. And in order to get an instance, you have to make one of them. And if you make one of them, you're going to be running that code. And you don't want to run the code in the parent's constructor function every time you extend it, because it could be doing something, it could have a side effect, it could be doing something. So you have to make a temporary function, make sure the prototypes are the same, make an instance of it, inherit from that, and then make sure you don't mess up the prototype or the constructor property. And then the last thing here, to be completely thorough, that is being done that's not standard is the copying over of the static properties from the parent class. And so that's how the stuff like has many works. Because it's a prototype chain, so you only have one level of objects, right? There's no distinction between the constructor function level and the instance level. Even though they're there in JavaScript, right? Even though you have constructor functions and you have instances of them, the inheritance is only for the instances. So we sort of do that by hand, and it's not ideal. Ideally, you'd have a real prototype chain for that as well, and you'd be able to have true inheritance and not be copying methods. But in practice, this lets you use those static functions in your class definition to do really useful stuff, and so that's the reason why that's there. Yes, sir.
So how much of this can be, I guess how much of the class's behavior can be changed after it's established? And are there any leaky abstractions that happen?
This is the one. The one that's leaky is the copying over of static properties. If I then change the parent's definition of that static property that's not going to be propagated. Everything else is standard prototypes. And if you change the parent's definition 2 or 3 levels up, even 2 or 3 levels down, that's just a pure prototype chain getting walked back up. So it's only in this case where you can't really do it in JS that is the questionable leaky abstraction that's being added. Yeah. All right. How are we doing? We're doing 10 minutes. Doing pretty good. So bound functions, right? We all know that in JavaScript here we've got a class called person. When you make one, you give it a name, and when it introduces himself, he's going to say, "Hi, I'm this dot name." I'm sorry, I didn't mention this, but at, like in Ruby, is for a local instance variable. It's just a shortcut in Coffeescript for this dot. So you don't have to write out those 5 characters every time you want to talk about this properties. So if we make a person called Mick Jones and we introduce him, it's going to say, "Hi, I'm Mick Jones." But if instead we had said, say hi equals Mick.introduce, right? Now we're pulling the function off of Mick, and then we call say hi. That function is going to forget what this is, right? Hi, I'm undefined. It doesn't know what this .name is anymore. So one convenience that Coffeescript gives you is it gives you the fat arrow. The regular arrow is a regular JavaScript function. The fat arrow is a bound JavaScript function. So if all we have to do is change the definition of introduce to say, keep this bound to the current value of this, and don't let it change. You can pass it to a jQuery callback. You can pass it to set timeout. You can pass it to a Node.js async thing, and the value of this will be preserved. So when we run this, now he remembers that he's still Mick Jones, and the value of this doesn't change. Pattern matching. So one fun thing that's in the spec for ES-Harmony is doing pattern matching. So you have your JavaScript object on the right, and you want to extract values on the left. So in the simple cases, this can be used for switching pairs, right? The variables A and B equal the values 1 and 2, and it's just doing positional matching. So in this case, B is 2, and it's probably doing what you'd expect if you compile it, right? You have a reference for what the right side is, and then you just extract the values for the left side and declare your variables. But this can be used for much fancier stuff too, right? So now we have a complex JSON object where you have a sculptor, a painter, and a poet. The sculptor and the painter are strings, and the poet is another object literal. The poet has a name, which is a string, and an address, which is an array with 2 lines in it. So now in our destructuring, and I'm going to zoom that back down so we can see it, we're digging into the poet, and we're pulling out the name value, right? We're digging into the poet's address, and we're pulling out the street and the city as the first and second line of the address. And there's actually a shortcut for this in Coffeescript. There's shorthand object literals. If you ever say name colon name, A colon A, B colon B, if it's the same on both sides, you can just get rid of that and just say name inside of a object. This is handy a lot in jQuery, right? Where it's URL colon URL, data colon data, all that kind of stuff. So when we run this, we're going to have FT Marinetti lives on Via Roma 42R because we pulled out those values from deep inside of that object. And finally, putting it all together, here's a quick example that uses a couple of these things in JavaScript and in Coffeescript from an intersect function. Using a splat instead of having to look into the arguments to pull out everything after the first argument, just saying, we're going to pull out everything after the first argument right there, using the indentation, using the fact that all of the values are being returned, using the shorthand functions. And then when you compile this, you get back something similar but not identical to what you started with something a little bit fancier for doing the splat right there, instead of using the _.rest function. All right. So what are we talking about here? We're talking about build your own JavaScript, right? Lots of features that end up in browsers are prototyped and implemented just in JavaScript first. Things that end up in Ruby, like symbol to proc, are prototyped and implemented by Rubyist before they get merged into core. So in JavaScript, there's stuff like function.prototype.bind started out in prototype.js. Object.defineProperty now exists in ES5 because of conversations about how do we extend core objects safely. right? Use strict exists because as a community we've decided to avoid using certain parts of JavaScript, like with that cause terrible performance problems and safety problems. You know, the JSON object exists because someone wrote a JSON object first and then it was standardized. The array extras that are now in ES5, map, reduce, filter, every, sum, were done in a lot of JS libraries before they were standardized. So all of this stuff is sort of participatory and not rocket science in any sense. So I think that we all should have the encouragement to scratch your own itch in JavaScript as in Ruby. You know, from a purely self-interested perspective, right? One of the nice things about targeting JavaScript as your compilation target is that, you know, hey presto, your code now runs everywhere, right? It runs in the browser, it runs on the server, it runs in Node, you can script Photoshop with it. It's sort of, you know, deeply ubiquitous. And probably because of the virtue of running on top of V8 or TraceMonkey under the hood, it's probably one of the faster dynamic languages, period, just because you're targeting JavaScript. So the oldest saying in the book for writing literature is really the same for writing code, right? You have to throw a lot of crap at the wall to see what sticks. And projects like Coffeescript and all of the languages that compile into JS, which I should probably take a moment to pull up here. There's a great website called altjs.org that you can go to, if I grab the browser, that has a huge, you might not have thought there'd be this many, but a huge list of languages that all target JS as their compilation target. And a lot of really fun stuff in there, right? Implementations of existing languages like Smalltalk, Haskell, OCaml, Lisp, Java, Python, Ruby, as well as flavors of JavaScript like Tracer, which is Google's new proposal for what they think that the next version of JavaScript should look like, but they're implementing it in the current version, so you can sort of comment on it and see how it works. So with the goal of making it easier for folks to get started with doing their own compiled to JS language prototypes, Coffeescript source code is all annotated. There's documentation in there that explains how it works. And I will show you in brief how it works. So the phases that you go through here are, you start with a source file of CoffeeScript text, like that one that we saw earlier. Let's go to it, in fact, where you have a function square that takes in x and it returns x times x, right? Our simple sort of hello world, make that bigger, of a function. And so how do we start? We're going to start by taking that function and turning it into tokens. So CoffeeScript has a lexer that goes through, it scans the source. Got two? All right. And it emits the token stream, right? So we have identifier square, param start, identifiers, the math symbol, and indentation getting lexed as tokens. You take the tokens, you pass them to a parser. So in our case, our parser is JSON, which is a JavaScript similar thing to rack that you can use in Ruby, where it'll identify your token stream. It'll do a bottom-up parse of them. It'll give you back a syntax tree. So if we do coffee -- nodes on the same file, we'll get back our syntax tree, right? We have a block of code. At the top level, you have an assignment of the value square to a code block, which is a function. And the code block takes one parameter, which is x, right? And then as its body, it has another block of code with an operation that's a multiplication, and then two x values. So there you have your AST. And finally, you can print that out as JavaScript, right? So if I print that out, I get back our JavaScript right there. All of the source code is annotated, like I mentioned, so you can read through the grammar and see how all of this stuff goes together. And to wrap up, it's okay to cheat if you have to. It's not rocket science. You don't have to be as purely theoretical as you might if you were doing a paper about it. CoffeeScript cheats probably in many ways, but one of the ways that we cheat is that there's an extra pass. There's a lot of implicit, so I guess, I don't know if Ruby cheats or not, but there's a lot of complexity in Ruby having to do with optional syntax. If you ever looked at Ruby's parse.y file, which has to basically parse everything, it's 10,000 lines of really complex YAC and C code to try to make that work. And we avoid that complexity even though we have pretty much as much optional syntax by cheating and rewriting the token stream before it's parsed. So resolving the ambiguities before we actually send it off to the parser. And there's a lot of projects out there that can help you with this. JSON is the one that we use. There's also Peg.js and Ometa if you like a Peg-style parser. And that is about it. So my main point is that if you've been afraid to work on something languagey because you think it's NASA rocket science, you shouldn't be, right? It's all just code. You can cheat if you have to. And if you feel comfortable designing a nice API, you should feel comfortable designing a nice syntax. And we really shouldn't be waiting for browsers to give us the language we want to work with, or for the ECMA committee to give us the language we want to work with, or for Mats or for Guido to give us the language we want to work with. You can give yourself the language you want to work with. And thanks.
All right.